Alright, y'all, we're going to start talking about goal 2.01. That is for you to be able to sketch a graph of high degree polynomials. We're jumping into degree 4, 5, 6, 7, 8, 20, whatever. Okay? So I got a couple examples for us. This first one is to sketch the graph of x plus 4 squared times x plus 2 cubed times x minus 3. Okay, I want you to notice one thing. This is in factored form. Okay, all of its factors are here. It's not in standard form. Factored form makes it a little bit easier for us to graph this. Okay? Now before we do anything else, I want to talk about something. The purpose of this goal is not for you to sketch a perfect graph. Okay? That's why I've got the word sketch underlined a bunch of times. Okay? We're just drawing a very basic graph that more looks at what happens as this graph crosses the x-axis, as it approaches its zeros. Okay, and remember you get your zeros from the factors. Okay? Graphs behave certain ways depending on a couple of things. And we're going to talk about those first before we jump head over heels into this graph. First thing that kind of affects how the graph behaves around the x-axis is something called the multiplicity. Multiplicity describes how many times something appears as a factor of a polynomial. Okay? We could have a multiplicity of 1, 2, 3, and we could have more than that, but just for now we're going to talk about multiplicities of 1, 2, and 3. If you have a multiplicity of 1, if something appears as a factor one time, as it goes through the x-axis, all it does is just kind of strikes through. Okay? Literally just a straight line on through it. Kind of boring. If the factor has a multiplicity of 2, it's going to do what I like to call a bounce off the x-axis. Okay? It'll just come towards the x-axis and bounce right off of it. Can't even connect my lines, can I? And if it's got a multiplicity of 3, it's going to kind of squiggly swerve around it. I think that's how you spell squiggle. I'm not an English teacher. So it's going to come towards the axis, kind of slow down a little bit, and then pick up speed. It kind of looks like a parabola that someone just bent half of it pointing down. Okay? And it looks like a cubic parent function too. Okay. Another thing that determines some behavior about our function is whether or not the degree is odd or even. Okay? How you determine the degree is you add the exponents. Okay? So 2 plus 3 is 5. So you may be thinking this is a degree 5 polynomial, but it's not. It's actually a degree 6. You got to be very careful about the understood 1 as an exponent for that. We don't write it, we don't type it, because everybody just assumes that if something doesn't have an exponent written, it's a 1. Don't forget to add that 1. 2 plus 3 plus 1 is 6. So this is an even degree polynomial. The degree kind of determines its end behavior. So where should I start and where should I end? Okay? Odd degree polynomials start from the bottom left of your graph. Okay? And they'll end at the top right. So bottom left to top right. Even degree polynomials start from the top left and end at the top left. Okay, now a little trick that actually one of my students last year started using to help himself is he would highlight the corners of the graph that was his starting and finish line. So I'm just going to highlight the corner right here and the corner right there. Okay? Now, one more thing before we actually get started graphing this. We've got to determine where it's going to cross the x-axis. Okay? How we're going to do that is we're going to look at our factors. If we have a factor of x plus 4, it's going to hit the x-axis at negative 4. You switch the sign. If we've got a factor of x plus 2, it's going to hit the x-axis at negative 2. And if it's got a factor of x minus 3, it'll hit the x-axis at positive 3. Now I think we are ready. We got to start from the upper left and end at the upper right, and we got to hit at these three locations the correct way. So, starting from up here, I'm going to approach the negative 4. Now if I look at my negative 4, the factor x plus 4 was squared. That has a multiplicity of 2, so we're going to bounce. So just come on down and bounce off the axis. Okay? Now remember, we're not too concerned about the y-axis really at all. Okay, we're just concerned about how it crosses the x-axis. As it approaches this negative 2, looking at the factor x plus 2, it had a multiplicity of 3. So as we turn ourselves around, we're going to have to do that weird swervy thing where it kind of slows down and then picks back up. Okay? We got to orient ourselves and get all the way over to this 3. Now in reality, this line would go all the way off the graph and down across my table and then back around up. Okay? We're not concerned about that. We're just going to turn ourselves around. This positive 3, the factor x minus 3, had a multiplicity of 1. So we're going to strike right through it. And that is a very basic sketch of this kind of polynomial that really kind of fleshes out what it does as it crosses the x-axis, what it does as we go away from its factors, its zeros. We see that it starts high, ends high, and crosses the axis 3 times in these specific ways. Okay? Remember, even degree polynomials generally start high and end high. Odd degree polynomials generally start low and end high. And that's generally, not all the time. That's actually going to be different for this next example. So look at this. There are 2 things that are a little bit different about this one. First, you may notice this negative right here. Anytime you have a negative, you flip it. Meaning, if it was supposed to start at the lower left, it's going to start at the upper left. And if it was supposed to end in the upper right, it'll end in the lower right. Okay? So basically, take these rules and do the exact opposite. That's only if you've got a negative out front. The other thing is one of our factors is x squared. Okay? I think we know that we're going to cross the x-axis at negative 3 because of the x plus 3 factor. And we're going to cross at positive 3 because of the x minus 3 factor. But it doesn't say x plus or minus anything. It just says x squared. Okay? Well, the number for nothing is 0. So a lot of people forget to cross it at the origin as well. But we need to cross the x-axis here, right at the origin. Okay? Now, counting up my exponents, this is a 2, 3, 4, 5, 6, 7. This is a degree 7 polynomial. 7 is an odd number, so I'd normally say start low and end high. Because this is negative, I'm going to start high and end low. Okay? So, going down towards our negative 3, the x plus 3 thing was cubed. So I'm going to have to do that weird swervy squiggly thing. I'm going to have to turn myself around and hit at the origin. It's squared, multiplicity of 2, so it's going to bounce right off. Got to turn myself around again and go towards the 3. The x minus 3 was squared, so I'm going to bounce off once more. And I see that as I bounce off, it does take me to the lower right. Okay? Remember, if you actually graph this in your calculator or in Desmos or something, these little humps right here would probably go way down because degree 7 polynomials get pretty big pretty quick. I mean, have you ever raised anything to the 7th power? It's a big number. Okay? Alright, if you have any questions, please let me know. Don't forget your even and odd degree rules. Don't forget your multiplicity rules. And be careful. Let me know if you have any questions. Thanks. Bye.